In 2026, at the heart of our global digital transformation lies a hidden paradox where agentic AI efficiency creates massive carbon footprints across industries. Every single token generated by autonomous agents carries a measurable environmental weight that traditional enterprise green frameworks often fail to accurately capture or report. Recent SOTA benchmarks reveal that high-performance reasoning models consume up to 10 times the energy of standard intent classification tasks in industrial automation. Silicon Valley and the European Union are now facing a strategic reckoning as energy per token metrics become the primary currency for sustainable IT infrastructure procurement. Data centers in 2026 are projected to consume over 800 terawatt-hours as generative AI workloads scale beyond the capacity of existing power grids. We must move past the hype of infinite scale to embrace a discipline of ecological restraint that aligns technical ambition with our planetary boundaries. Today we will master the technical architecture of sustainable digital transformation by measuring the precise energy per token cost of your enterprise agentic reasoning workflows. Participants will gain immediate access to carbon-neutral green AI frameworks that integrate environmental, social, and governance metrics directly into 2026 global governance roadmaps. Our objective is to optimize your inference stacks by strategically shifting from large foundation models to highly efficient task-specific small language models for production. By the end of this session, you will be equipped to architect resilient digital ecosystems that prioritize both high-performance intelligence and verifiable environmental stewardship. The 2026 landscape is defined by the tension between rapid agentic adoption and the urgent need for transparent reporting of Scope 3 carbon emissions. Industry leaders at the World Economic Forum have highlighted that training a single large model emits carbon equivalent to 500 transatlantic flights today. Current pain points include the lack of standardized methods to track water consumption and e-waste generated by the specialized hardware required for LLM training. Organizations are struggling to reconcile their net zero targets with the non-linear energy demands of multi-agent systems that operate in real-time edge environments. The shift towards sovereign AI in France and Brazil further complicates this as regional energy grids struggle to support localized high-density computing clusters at scale. NIST and the OECD are now emphasizing that digital sovereignty must include energy autonomy to ensure that AI transformation does not compromise national sustainability goals. We are moving from an era of model accuracy at any cost to a new paradigm where efficiency is the ultimate driver of ROI. Understanding the true unit economics of a token is no longer just a financial necessity but a core requirement for strategic 2026 leadership at Experto TIC. Pillar 1. Measuring agentic energy consumption. The first pillar focuses on calculating the energy per token cost for agentic reasoning, which often involves multiple hidden recursive loops during complex task resolution at scale. In Canada, CIFAR research teams are utilizing the Perun framework to benchmark GPU joules per inference pass across diverse hardware architectures and model sizes. Technical teams must implement real-time monitoring of CPU and memory utilization to identify wasted energy in long-running autonomous processes that fail to terminate. By quantifying the carbon intensity of each prompt, we can finally make the environmental impact of AI visible and investable for boards and stakeholders. Pillar 2. Strategic ROI of small models. The second pillar leverages small language models to drastically reduce inference costs by up to 90% while maintaining competitive performance for domain-specific applications. Benchmarks in 2026 show that models like DeepSeek and Mistral 7B can match older foundation models at 1% of the operational energy cost. Digital transformation ROI is maximized when organizations deploy a modular stack of specialized SLMs instead of relying on a single resource-intensive frontier model. This strategic shift enables sub-second response times on edge devices, which is critical for real-time manufacturing and emergency response systems in modern smart cities. Pillar 3. Post-quantum green defense. The third pillar integrates cybersecurity and ethics by adopting carbon-aware workload scheduling that shifts heavy processing to times when renewable energy is most available. In the EU, ENISA guidelines now mandate transparent emissions reporting for any AI system used in critical infrastructure to prevent hidden environmental risks from scaling. Post-quantum cryptography must be implemented using energy-efficient algorithms to ensure that long-term data security does not result in an unsustainable surge in compute. Ethical governance roadmaps at AI Knowledge is prioritize the right to repair and circular hardware lifecycles to mitigate the rising tide of specialized AI-related electronic waste globally. Pillar 4. ESG Governance Frameworks. The fourth pillar establishes a comprehensive governance framework that embeds ESG metrics into the lifecycle of every AI agent from design to decommissioning. The 2026 AI Act in Europe requires companies to disclose the water footprint of their cooling systems, particularly in regions facing severe climate-related scarcity. Global enterprises are adopting the ESG AI toolkit to align their digital innovation with societal goals and support responsible investments in green technology infrastructure. Governance must move from branding to implementation by ensuring that sustainability is not an afterthought but a core design constraint for every lead architect. Let us examine a real-world implementation of a carbon-aware inference stack using the NVIDIA Blackwell platform to achieve a tenfold reduction in cost. Our GitHub reference architecture includes a Python script for estimating carbon intensity by pulling real-time grid data from the Energy Intensity API during execution. The demonstration shows how to trigger a fallback to a quantized SLM when the local energy mix exceeds a predefined carbon threshold per token. We will review a prompt engineering strategy that reduces input tokens by 50% without losing the semantic context required for high-accuracy agentic reasoning. The architectural blueprint incorporates liquid cooling optimization and reinforcement learning to distribute workloads across global data centers based on the current renewable energy availability. This hands-on approach proves that we can build powerful intelligence that is also purposeful and respectful of the resources it consumes in 2026. The final moment comes when we realize that technical efficiency and business profitability are perfectly aligned in the era of sustainable digital transformation. By optimizing for the token, we are not just saving the planet, but also reclaiming the margins that large foundation models have traditionally eroded. Sustainable AI is the ultimate catalyst for better engineering as it forces us to build leaner and more resilient systems that scale gracefully at Experto TIC. The transition to a carbon-neutral AI workforce is the defining challenge of our generation and the key to long-term digital sovereignty in the Americas. Your roadmap for 2026 starts with a full audit of your current AI energy consumption, followed by the strategic integration of SLMs into production. Follow at AI Knowledge is power for daily deep dives into the SOTA benchmarks and global research protocols that are shaping the future of green technology. Join our community of lead architects as we pioneer the frameworks that turn environmental responsibility into a competitive advantage for the global tech economy. Turn knowledge into your greatest asset. Channel powered by generative AI architecture.